This is Chapter 7, Section 9. It's going to talk about passing objects to functions. And so just like you can pass primitive data into methods or into functions, you can also pass objects. And so when passed by value, the function makes a local copy of the object, and the original object in the calling environment is unaffected by actions in the function. When it is passed by reference, the function can use set functions to modify the object. And so depending upon how you actually want the object to be used, you may want to pass by value or pass by reference. When you do this, using a value parameter for an object can slow down a program and waste space. So it is probably not done that frequently. Using a reference parameter may speed up the program, but also allows the function to modify the data, and you might not want that. Meaning you want the efficiency of passing by reference, but you don't want to change your original data. So there's a way to work around that. In order to do that, to save space and time while protecting parameter data that should not be changed, we use what's called a constant reference parameter. And what that does, or what that means, is in front of the value that we're passing, or the data type, like square is the type of data that we're passing, we're going to put a constant, C-O-N-S-T, specifier, and we have to use the ampersand to show that we're passing by reference. So we've got three things going on here. We're passing a square object, we're passing it by reference, thus the ampersand S, and we want to make sure that that data doesn't change, so we use a constant in front of that. Then in order for us to show the data function to call the square member functions, those functions must use a constant in their prototype. So we also have to go and change the prototype and make it a constant. You can also return an object from a function, and what that kind of means is you have to then make a local object and then return that value from a function. So every function can return, or any function can return an object or return something if we want. It can be primitive or it can be a function. So we have to declare a local item of the whatever data type we want to return. In this example, they're saying that it's going to be a square. The function must define an object for internal use and then use that value to return it. So what this line here is saying is that square is going to it's going to create a square, init square. It is using the default constructor with the params here. And then S1 is going to be assigned init square. So init square is going to return a value and assign it to S1. That's the call. The example for returning an object, this code is in our textbook, and I think I'm going to pull that up on Visual Studio. Keep in mind that you have access to all the source code files in the textbook, and I will show you where to find them. Okay, the textbook did not have that example pre-written, so we're going to use the circle class example again. And what I'm going to do, we want to demonstrate passing a object to a method. And so I'm going to look at my code, and I recognize that this code is repetitive, which is a good time for me then to consider what we call refactoring. So I decided to write a method that's going to refactor the display results, and every single one of these methods, or excuse me, outputs is exactly the same, except it's using a different object. So what I'm going to do is to write a single method, and it's going to take in a circle, and then I'm going to repetitively use that method to print out each circle. So I should be able to call that method print results like this and send it circle1 as an object and get it to print the results. And then I will call that method 3 times. So I'm going to copy and paste and just send it circle1, circle2, circle3. So we're going to start with seeing if we can get this to execute. I'm going to highlight these lines of code, comment them out, So we can come back to that if we need to. The other thing that I need to make sure of, there's a couple of things that we need to do when we are writing this code. Number one, I'm creating a method for this main driver, basically. It is not a method that's actually inside my class, although I could write that inside the class. I decided to write it here just to demonstrate a couple of things, because they talked about creating a prototype line, and so I need to create a prototype line above main. And to make this a little bit easier maybe to see the whole program, I'm going to use this shortcut here where I close the circle class, and then I'm going to uncomment the prototype. So my prototype is, it's no return value, it's print result, and I send it a circle. So if I execute this code, I should get the exact same output that I did before. I refactored the code. And on my other screen is the output. I'll bring that over. So we have the exact same output that we had before. Okay. Now, the other things that the slide was referring to, though, was that takes overhead. And so rather than passing it by value, which is what I just did, we want to pass it by reference. So if I pass by reference, it starts to throw some errors. So we're going to have to look to see what's going to happen here. But the idea, and what's probably happening, is it's going to say, let's look at the error message. It says more than one instance of an overloaded print results matches that argument list. So it's saying, I know I have a circle, but I don't have a circle. So overloaded is the same name, same parameter type, and what it's looking for is the fact that we don't have the ampersand down here to pass the circle in by reference. And okay, I'm trying to remember if I believe that ampersand can also be right next to the data type like that. It might also be acceptable to put it after like this. I don't know if it will throw an error. Oh, that throws an error. So we want to have the ampersand in front. And we want it to be an ampersand, not the number 7. All right, I'm going to, again, run the code just to make sure that it executes. And this error, this isn't an error message, but when you're using Visual Studio, this will come up again and again and again. And at this point, you always want to click yes. So you can choose to do not show this dialog again and click yes, and then your code will execute. And I use that shortcut key up here, which is why I also put in that system pause. And my execution ran off to the side, and here it is. We get the same results. So a pass by reference didn't change the results at all, but behind the scenes it took up less processing. We couldn't see that, but that's what it did behind the scenes. The other thing that we want to make sure of, though, is that we can't arbitrarily maybe change a value in here. So for example, what happens if I am working with this circle and I say circle dot, and I do set radius, and I set the radius to 5. And if I do that, then I'm passing in circle 1, 2, and 3. If I change that locally, which means I'm changing the value of that local circle, then my output looks like this. It changed every single one of them to 5. The diameters are 10, and the area is 78.5. So what that's doing is it's taking the value that I sent in and altering it and then printing new results. Well, we don't want it to do that. We want to preserve that, so we're going to create this as a constant. And I don't remember whether the constant goes before or after the ampersand. So now it starts to get ugly, okay? So first of all, it's not compatible with the circle set radius, all right? It says object type is constant circle, so it's yelling at us, telling us so we can't do that. So if I take out that one line of code, that's going to be okay, but I get an error here. Also that it's incompatible with the member function getRadius. I don't really think that's an error. I think that'll clean up. What I do think that we need to do though is put the constant specifier in our prototype. And so we will see what happens. Okay, it is not going to let us use that circle that's being sent in because it's a constant. I did switch up a couple of things to try to find the error, and there's two things. I changed where I put the constant so that it matched up where it was in the prototype right here in our and let me go ahead and close that class again. But what's going to happen is this. There's a couple of things. Number one, if we look at the PowerPoint slides again, it says here that we have to change the prototype and the header. And so we changed the header, but we would then need to go in and change the prototype of the function. I attempted to do that. If we go back to that code, that means we actually have to go into the circle class and we need to try to change the header here. And I wasn't able to actually get it to work. Like if I try to say that I'm going to return a double constant, it kept throwing error messages. And part of that, it says the object type qualifiers are not compatible with the member functions no matter where I put the constant. If I said I was going to be returning a constant, if I followed the example here where I put const right after it, etc. And part of that, for example, if I did const there, it did not work. We can try that just to show you, which is what the sample did. And that's because it's looking for this in a what we would call a header. This box always comes up if you have errors, so we say no, we don't want to run the last successful build. If you happen to accidentally click yes, then just an FYI, you can always go up to debug or to build and do a clean or do a rebuild, so it resets it. Otherwise it'll keep running the last successful build. But that didn't clean up the message. And part of the reason for that is, this is going to be in some further slides, is that we have our class defined within the same program we have main, and now we have these other functions as well. And so what we need to do to clean this up for right now is as follows. I need to use a local value of circle in order to get this to run, meaning the following. I am going to change this parameter name to just C. I'm going to create a local value circle and assign it C. So the reference is getting passed here, and now I have a local instance of circle, and now it's letting me access those values. So if I run it now, we're going to see if that fixes our error, and I believe it will. It's not how we want to fix it forever, but that's how it will fix it for now. Okay, and so those are the results that we are expecting. So we've got it working again, and it is, we know that it is, we saw that we couldn't change the data, so that data is protected if I'm passing it as a constant. So that's the whole thing that they wanted to kind of get across, is that if you pass objects, you want to pass them by reference, and you want to pass them as a constant because they take up overhead. As you guys are learning or working on this and practicing with it for right now, you guys could just go ahead and pass them without making them a constant. But later on, when you start to work with some of your semester projects and stuff, you would want to then start to follow the correct way, or the better way to pass those is by reference and making them constant. So we'll talk about that a little bit later on, but that's going to cover the last two slides, or the last few slides on, that was section 9. Okay.